Alright, so here's some more practice problems, right? So function f, we have to restrict the domain so that's greater than or equal to 0, which means that x has to strictly be greater than or equal to 1. My domain here. The function g, my second function, it's a parabola that's just shifted to the right by 1, so there's no restrictions, right? So it's all real numbers. So starting off, we have function f of g of x, which means that my function g brings its domain restriction, which in this case, there is no restriction, right? It's all real numbers. And so we're trying to figure out, okay, well, what's going to be my new function, right? So what's going to be my new composite function? So it starts with my outside function being function f. So I'm going to start with square root. I have an x, so I'm going to leave parentheses, minus 1, and then where I left parentheses, I'm going to replace it with my function g, which in this case was x minus 1 quantity squared, right? So from here, we can kind of see that we are definitely going to have a new domain restriction, right? Because this has to strictly be greater than or equal to 0, and so that's kind of what we're going to focus, right? So because function g is not really bringing a domain restriction because it has all real numbers, right? But my new composite function, we definitely have to restrict the inside so that it's greater than or equal to 0, right? So we take the inside, so we have x minus 1 quantity squared minus 1 has to strictly be greater than or equal to 0. So then we're going to solve this. We're going to focus on this. So then we have x minus 1, and again, there's many ways you can go about it. We're just going to move the 1 over, and then we're going to square root both sides, right? So square roots, and that gives me x minus 1 greater than or equal to plus or minus 1. So the fact that we have two values here, right? We have a plus or minus 1 means that we have this, right? So negative 1, x minus 1, then positive 1, right? So we're going to have two separate solutions. So the way I look at them is we're going to focus on this part first, right? So we have negative 1 is greater than x minus 1, solve for x, subtract 1. So we have negative 2, add 1, sorry. So that's 0. So that I'm saying x has to be less than 0. That's one of my restrictions. The other one is that other side, right? So here we have x minus 1 greater than 1. Solve for x, so we get x greater than 2. So these are my two restrictions for my domain, right? So my new function, and we're going to go ahead and simplify here, right? So starting from here, here's my composite function. So we have the square root of, now when we square that, we get x squared minus 2x plus 1 minus 1. And then we have x squared minus 2x, and that the plus 1 and minus 1 goes away. And so that is my f of g of x, right? That is my composite function. And so here you can kind of see, okay, well, the stuff has to be greater than or equal to 0. And so my two values is x has to be less than 0 or has to be greater than 0. And the fact that there is no fraction here, it's or equal to, right? So my domain, if I want to write it in interval notation, so x being less than 0 means we're coming from negative infinity all the way to 0 included. And we're going to start from 2 all the way to positive infinity, right? So how can we check real quick? Well, if we plug in negative 10, right? So this is kind of what I'm doing in my head, right? So the two values that make it 0 was 0 and 2. And we're going to choose values and we're going to test them in here, right? So my function in there and see, do I get positive values or do I get negative, right? So the goal here is to get positive, right? We don't really care about whether we get negative or what the actual value is. We just care about whether we get a positive or a negative, because we cannot be negative inside the square root. So let's make life easy and let's choose a value like negative 10. If I plug in negative 10 in here, right? If I plug in negative 10, that's 100 minus 20. So that's a positive 100 well, actually a negative makes that positive, so that's a positive plus a positive is definitely positive, right? So some number between 0 and 2, well, 1 is a number between 0 and 2. If I plug in 1, I'm going to get 1 minus 2, which is definitely negative, right? So that means that any number between 0 and 2, doesn't matter what the number is, as long as it's between 0 and 2, I'm going to end up getting a negative inside my square root, which I don't want. And then same thing, so choose a number somewhere to the right of 2. Let's go with 10. All right, let's make life easy. If I plug that in, that's 100 minus 20, which is definitely positive. And so that means that any number that I choose that is to the right of 2, I'm going to end up being positive, right? And so here is kind of my final answer, right? So my composite function is the square root of x squared minus 2x. And my domain restriction is from negative infinity to 0 included, and from 2 to infinity included, right? In a bit, we're gonna go ahead and graph them just to confirm our answer. But let's see what let's see what g of f would have looked like, right? So g of f of x means we use our function g as the outside function, right? So we have parentheses, and it's going to look weird, but we have an x minus 1, and that quantity is being squared. Wherever we put a parentheses, we're going to replace it with function f, which in this case, function f is the square root of x minus 1, right? And then we go from here. And so we have to remember that function f is bringing in its domain restriction of x greater than 1. Now the fact that we are squaring this, that means that really my only restriction is going to be x has to strictly be greater than or equal to 1, right? And so you can simplify that, but my domain restriction is going to end up being x greater than or equal to 1. All right, so let's graph these and confirm our domain restrictions. So we're going to go to our graphing calculator, and the first one was f of x is the square root of x minus 1. I put that right here, right? And again, the domain restriction is 1 included and everything to the right of that. Our second function was x minus 1 quantity squared, which again is just a parabola shifted to the right. And so our first one was f of g of x, and we set everything to the left of 0 and everything to the right of 2. And so here we have f of g of x, and we can confirm that my graphics is from the left of 0 included, from the right of 0 included, right? And we said for the second one, my g of f of x, the domain restriction was going to be all x values greater than or equal to 1. And so we graph that, we get this funky looking thing, right? But nonetheless, my domain restriction is everything to the right of 1 included, and that's what we have.